Hi, today we're going to do lesson 3-2. That's use parallel lines and transversals. The big question here is how are corresponding angles and alternate interior angles related for parallel lines and a transversal? So obviously we're working some more with transversals on this lesson. So our first part, corresponding angles postulate, it says if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So you talked about corresponding angles in the last lesson in 3-1, and you should know angle 2 here and angle 6 are corresponding, so they're congruent. These two angles would also be corresponding, so they're congruent. These two are corresponding and they're congruent. We know these are vertical, so they're the same. And then these two are corresponding, so they're congruent as well. The key thing, though, is they're parallel lines. That's when we know this is true. Alternate interior angles theorem. If two parallel lines are cut by a transversal, again, we got parallel lines here, cut by a transversal, then pairs of alternate interior angles are congruent. So these two would be alternate interior angles. They are congruent. These two would also be alternate interior angles, and they are congruent. Alternate exterior angle theorem tells us if two parallel lines, again, we've got parallel lines, are cut by a transversal, then the pairs of alternate exterior angles are congruent. So alternate exterior would be angles 1 and 8 here. Those are congruent. These two would also be alternate exterior angles, and those would be congruent as well. Consecutive interior angles theorem. This says if two parallel lines are cut by a transversal again, so once again, parallel lines being cut by this transversal, then the pairs of consecutive interior angles are supplementary. Notice this is different. Okay, they're not congruent, they're supplementary. So that means they add up to 180 degrees. So in this case, angle 3 and angle 5, the measure of angle 3 plus the measure of angle 5 has to equal 180 degrees. The vertical angles congruence theorem, and we've talked about this in class already. We've talked about how angles 1 and angle 3, those are vertical angles, and they're congruent. And also angles 2 and angle 4, those would be congruent as well, and they are vertical angles. We've talked about this one, so that shouldn't be new for you.
For those of you interested, swing dancing is now taking place in room 28. Also with Kelsey Klingenberg, please call the switchboard.
Sorry about that little interruption. Let's keep going here. For example 1, identify congruent angles. So the measure of angle 7 is 75 degrees. Find the measure of angle 1, and the measure of angle 3, and the measure of angle 5. Tell which postulate or theorem you use in each case. So we know that angle 7 here is 75 degrees. Angle 1 right here, that's also going to be 75 degrees. And we know it because they're alternate exterior angles. So this is by the alternate exterior angles theorem. Angle 3 would also be 75 degrees, and we're looking in relation to angle 7. These two are corresponding angles. So that is by the corresponding angles postulate. And the measure of angle 5, well, angle 7 and angle 5 are obviously the same. They're both 75 degrees. We've talked about this one before as well, but that's because of the vertical angles congruence. Congruence theorem. So try the next example on your own. Try extra example 1 on your own. Pause the video and try it. Okay, welcome back. The measure of 3 of the numbered angles is 125 degrees. Identify the angles and explain your reasoning. So if this one's 125, quickest, easiest one that I can think of is this one as well. Angle 1 is 125. And that's by the vertical angles. I'm just going to write that for angles. Congruence theorem. Okay. The other one would be angle 7. So angle 7. And that's by the corresponding angles postulate. And then the final one that would be the same as angle 5. And we're looking in relation, angle 5, in relation to this 125 degree angle. And so that's by the alternate interior angles theorem. Okay, example 2, use properties of parallel lines. So because these two lines are parallel and they're cut by a transversal, these two are alternate exterior angles, so we know that they are congruent. So I can say 113 equals 3x minus 4. Here's my middle. I'll move the 4 over here. So I have 3x equals 117. Divide them both by 3, and x equals 39. And let's just double check. It doesn't tell us exactly what to do, so we're just going to find x. X equals 39 degrees. And you should check this to make sure it's right. If I plug 39 in here, 3 times 39 minus 4, you would want to make sure that does equal 113, and it does indeed equal 113 degrees. So we found the value of x here. Here's my equations, which I just wrote up there. Try this one on your own. Okay, so this one's a little bit different. We know these are vertical angles, so can't this one also be 3x minus 7? Now these two together, those add up to 180 degrees. So we can write the equation 3x minus 7 plus x plus 5 equals 180 degrees. Solving this, here's my middle. I'll move the 7 over, it becomes plus 7 over there. I'll move the 5 over, it becomes minus 5 over here. So like terms give me 4x equals 182. Divide both sides by 4. And x equals 45.5. And that's okay that it's a decimal because sometimes we will have decimals for these. So we found our value for x. Let's just do our check to make sure it's right. So both of these should equal the same, or I'm sorry, they should add up to 180 degrees. So for this one, I've got 3 times 45.5 minus 7. Here I have 45.5 plus 5. So this one's 50.5. And this one is 129.5. And let's just check. 129.5 plus 50.5, does that equal 180 degrees? Well, if you put that into your calculator, just combine them in your head, yes, it does equal 180 degrees. Let's solve this real-world problem here. It says a taxiway is being constructed that intersects 2 parallel runways at an airport. So we know these are our 2 parallel runways, and this right here is our transversal. You know that the measure of angle 2 is 98 degrees, so this is 98 degrees. What is the measure of angle 1? So let's look here. Angle 2 and angle 1, well, they're alternate interior angles, so we know the measure of angle 1 has to equal 98 degrees, and the how do you know part? Well, that's because of the alternate interior angles theorem. And we don't need to all that. So my extra example 4, right down here. Suppose angle 3 is the consecutive angle with angle 2. What is the measure of angle 3? So let me go ahead and erase all this. We've got a lot of extra stuff on there. So suppose angle 3 is the consecutive angle with angle 2. So here's angle 2. Consecutive would be right here. That's angle 3. So we know that these two angles are going to have to add up to 180 degrees. So this is 98 degrees. So I can say 98 degrees plus the measure of angle 3 must equal 180 degrees. So if you just subtract 98 degrees from both, the measure of angle 3 must equal 82 degrees. And that is all for these notes. We are now finished. So let's end this show and have a good night.